Hi everyone! In this video I'll show you how to install the Hamilton UI we just recently open sourced. So there's not that many steps, but we'll go through each together. If you go to the Hamilton documentation, under Concepts, Hamilton UI, you'll find this page that includes everything you need to know. So the first step is to get the Hamilton repository on our local machine. So I created a folder named Tutorials, and I will clone the Hamilton repository. Should only take a few seconds. It contains the entire Hamilton code base, and we added to it the cd Hamilton UI, the new Hamilton UI subdirectory, and we should see it on the left. It includes the backend, the front-end code, and the SDK. The SDK is the Python code we'll use to add a tracker to our code. And under deployment, there are a few scripts and Docker files to build the application. So this will be our next step. We did go to Hamilton UI, and we will run the deployment.run shell script. This is essentially wrapping Docker commands, and we're already building our Docker application. We're getting the backend and the front end from Docker Hub. The images are hosted by, well, they're produced by us, so they're reliable and they're secure. But if you want to build the Docker images yourself, you can do so by following these steps. We also provide a dev script, but know that this takes much more time, and also more memory needs to be allocated to Docker to be able to complete these steps. Usually just getting stuff online takes me about a minute for downloading different layers. This attempt was very fast, and then it will launch the application. This should take a few seconds. I'm on Windows and I'm using the Docker desktop application. And we'll see here the different images that were pulled. It's about 1.3 gigabytes in total that needs to be stored on disk. And it will create the two volumes. So the Postgres data and the backend data. This is data that is persistent on your machine. So if you need to clean things up, you also need to clean these volumes. But this means that if your containers go down or they're deleted, you won't lose your data. And here we see the Docker Compose stack called UI currently running. This is the same thing as what I have here. And we see that the default port is 8242, so we'll get to it. The first time you connect, it will ask you for your email. This is never communicated to us. In fact, you just have to put any string that has a @ character as part of it. So I'll say mydomain.com. This string is used to link the run of your Python code to your profile, so you can manage the read and write access to your projects. It doesn't really matter if you're a single user, but if you get set up for a team, for example, and you're running Hamilton UI on a server, and you're setting up authentication, this starts to matter more. If you need to get set up to run Hamilton UI on a server, please let us know on Slack and we will be happy to help. We have a few more instructions here, but what we need to do first is create a new project. We'll call this one YouTube tutorial. And you must input a project description. This is just to have a bit of metadata about what you're doing. So my project, task 1. This is just to showcase that this will be rendered as Markdown. And by default, we have write access. You can have users that only have read access, so they can consume the metadata from your projects, but don't have the right to add runs to it. And then it gives me again like a code snippet to get started. We'll copy that. And to showcase how we would use this in our Hamilton code, we will go to examples under lineage, for example, and we will modify the code from lineage script. There's a bunch of code here that's relevant for lineage, but not necessarily for us. So we'll just copy paste that here. One thing we will have to do is to create a virtual environment with the dependencies. So let's go to Hamilton, examples, lineage. We'll create a new Python virtual environment. This shouldn't take too long. And in each example folder, we have a requirements.txt. So we can do, first I need to activate my environment. Okay, activate. And so I can install the requirements with pip. Most of the packages are cached on my machine, so it only takes a few seconds. We're getting scikit-learn in particular for this example here. And the other thing we need to grab is the Hamilton SDK. It's available through SF Hamilton, and you can specify optional dependencies with the square bracket, and we'll write SDK. It can help sometimes in certain shell environment to add double quotes, but it's the same thing. So we got this working, and if we do pip list, we now see SF Hamilton and SF Hamilton installed, meaning things should run as expected. Just to show, we have ID completion for Hamilton SDK because we properly installed it. Import Hamilton tracker. I will refactor this. Okay. So looking at what's underneath, we want to get to this execution, let's say, and we'll delete the rest. It's not relevant for us right now. Just trimming the code a bit. Okay, so we have the driver, and we have the previous driver API that we don't need. So those are modules, they're Python modules. We see that they're imported here. We define our data flow, and we will pass them to with modules of the builder. And the config in this case is empty, so we don't need to specify config. And the adapter is no longer, like it's the default adapter, so we don't need to specify it either. So this should be equivalent to what we had before, but we also added the Hamilton tracker via the with adapters. The Hamilton tracker is simple, it needs a project ID. This matches the index here, so this is project 1, and we see in the instruction it says to link it to project number 1. It has my username. It has a DAG name because the project can have many DAGs, so we'll call it my first DAG. And the tags are optional. They're just like helpful metadata that you can use for filtering and querying runs afterwards. So I suggest using those, but in my case, I will remove that. Okay, so the only thing we need to change is this is a function to visualize execution, but we want to execute the code. So this is execute. Those are feature encoder. We don't care about this. We just want to get the inputs. And let's run this code. Python linear script. Hopefully this will work on first try. Hey, so we see that it says there is capturing the execution run. So it's starting and it captured the execution run, meaning it succeeded and completed the capture. And it gives us a link. Otherwise, like this would be accessible through the project view, and runs, history. So we see that DAG version, my first DAG. We have the set of nodes. The visualization is quite cool. You can group them, for example, by module. You can also show the code associated with each node. This is not necessarily the view you would use all the time, but when you have like specific questions about like what happened to my data, like how come it's like you have results that you're surprised by, this can be helpful to quickly answer these questions, and also how different nodes depend on each other. You also have a minimap down there. And the other view I want to show quickly is the code view, where you have all the code involved organized by module. And you can navigate through it and see how it depends on inputs and outputs. That's about it. If you have more questions, feel free to go to our Slack channel and or you can write to me directly, and I'll be happy to help. See you in the next video. Ciao.